Hello, everyone. It's 2 p.m. 01. I will have the pleasure of hosting and moderating this talk and giving you a bit of perspective of CloudFerro and the Horizon Europe and of a cloud provider. But this will be at the end. Today's agenda is my small introduction. Then we'll have a pleasure of listening to Ms. Solimini. Talking about the Horizon Europe opportunities managed by EUSPA. Afterwards, Mr. Taras Matseliuk will talk about what exciting solutions and applications can be done and has been done with in his company and with his input. And I will finish up our webinar for the last 15 minutes talking about how you can approach us and what you can do with us, with our company, how you can leverage the capabilities that a DIAS, specifically Creo DIAS, can provide to you in terms of answering to Horizon Europe calls. So first of all, I will take the liberty of the host, I suppose, and introduce very, very briefly our company. For those who do not know, CloudFerro is a relatively young European company. We have originated in Poland. We're located in Warsaw. We were founded in 2015. And for the last 7 years, we have experienced pretty rapid growth to the point where we have infrastructure in 4 European countries. We have built, delivered, and now operate a number of public, private, and hybrid clouds. We operate big data sets and big data repositories for Earth observation data. We do it all using open source technology. We do it in a way that allows us to own the whole technology stack. We have the knowledge to build from one end to another a public cloud for Earth observation data, storing, processing, and dissemination. So we are very able and very willing to cooperate on many different levels, as we have done throughout the last years, and as I hope to show you shortly. It's very important to us to be European. That's something that we put a great emphasis on, and that's also why we want so much to be a strong participant in the Horizon Europe, in European initiatives, and in building a better future for the member states and for European societies. And now I would like to ask Ms. Solimini to take over and talk about the opportunities prepared by EUSPA.
Thank you, Stanislav. Good afternoon, everyone. Stanislav did a very nice introduction. I'm Chiara Solimini, working now at the EUSPA, the European Space Agency, for the space program, and I'm space downstream market officer there. Today, I'm going to present you some opportunity we have currently open regarding the Horizon Europe work program. In particular, we have open a call on the topic of EGNSS and Copernicus applications fostering the European Green Deal. The call was open at the end of October. The indicative budget is 14 million. The type of action is an innovation action. And the deadline for HORIZON is for the 16th of February for the submission of the proposals. You can see in the slide the topic code, and proposals should focus on the development of innovative EGNSS and Copernicus applications that support the implementation of the European Green Deal objectives and its related policies. For example, the objectives described in the Green Deal roadmap, such as zero pollution ambition for a toxic-free environment, supplying clean, affordable, and secure energy, accelerating the shift to sustainable and smart mobility. The indicative budget for each project is around 2-3 million. The expected TRL is 7-9, so quite mature solutions. The applications developed is very important that have a clear commercial potential and that address very well identified user needs. The applications should be a real commercial impact and market uptake. In particular, the business plan is mandatory as well as user engagement. This should be delivered together with the proposals to ensure the user needs and the sustainability of the project. More details can be found on our website. I encourage you to have a look and to see the details. I can share the link later. So the topic we have is EGNSS and Copernicus applications fostering the European Green Deal. So the solution developed for all the areas of this call should use Copernicus EGNSS or the synergy of the two systems together with the integration of cutting-edge technologies such as blockchain, Internet of Things, 5G. In particular, the solution developed for all areas should leverage on Copernicus data or core services products, including Copernicus contributing missions and/or EGNSS differentiators such as high accuracy services, HAS, authentication features, or Galileo Open Service with multi-frequency capability, and may integrate, as said before, cutting-edge technologies such as Internet of Things, 5G, drones, augmented or mixed reality. Proposals submitted under this topic can be submitted in any of these 7 areas of interest. Increasing the EU's climate ambition for 2030 and 2050, supplying clean and affordable and secure energy, mitigating natural hazards, accelerating the shift to sustainable and smart mobility, building and renovating in an energy and resource efficient way, from farm to fork, a fair, healthy and environmental friendly food system, preserving and restoring ecosystems and biodiversity. So you can submit proposals on any of these 7 areas of interest. Now I'm going to show you some of these areas of interest. I'm going to show you some applications that we have identified with the use of Earth observation, EGNSS, or a synergistic approach to give you some examples. And also I'm going to give you some hints of the key trends in these areas, hopefully to give you some inspiration for the submission of the proposals. So, oops. First area, we are looking, is regarding the increasing the EU's climate ambition for 2030 and 2050. What we are looking here? We are looking for EGNSS and or Copernicus-based solutions which contribute to CO2 reduction and a toxic-free environment through better monitoring and preventing pollution from the air, water, soil, and consumer products, as well as natural catastrophes and pollution sources. Some examples of applications, but of course not limited to, may include environmental resource management, environmental auditing, impact study, and ESG, smart waste management. As you can see, there are different colors on the right part of the slide. In green, you can see Earth observation related applications, and in gray, more synergistic application leveraging EGNSS and Earth observation. What are the key trends we have seen in this area? Broadly, more in general, global climate policies are driving demand for data and services. More and more companies move towards an environmental, social, and government, ESG, mentioned before, culture. The use of Earth observation, GNSS, to fight against environmental crime in the domain of waste disposal. Environmental compliance assurance has just been defined as a self-standing concept. Yes, in EU policy, environmental compliance requirements create opportunities for emerging Earth observation markets. So this is a very interesting area, and where Earth observation is really broad. Okay, now I'm going to show you area number 6. I thought this may be of interest. Is related to the farm to fork strategy within the European Green Deal, as you know. So this area is from farm to fork for healthy and environmentally friendly food system. What we are looking here? Here we are looking to the development of applications and solutions based on EGNSS and Copernicus for food security and traceability across the entire supply chain and valorization of the made in Europe. Precision or digital farming solutions which reduce significantly the use of chemical pesticides and fertilizers and help saving water for irrigation. Innovative tools that support the digitization of post-2020 CAP, Common Agricultural Policy, or other agri-environmental policy. Some example of applications. As you can see, this area is very, very broad. You can use Earth observation, which is a very powerful tool, but also EGNSS. Example include natural resources monitoring, environmental monitoring, weather services for agriculture, operations management, smart farming, precision irrigation. Is very broad area, and as I said before, we are looking for innovative solutions leveraging on EGNSS and Copernicus, and please bear in mind that should be commercially viable solution. What are the key trends in this area that we have seen? Technology is really running fast. Cutting-edge technologies combined with EU space data and services are transforming precision agriculture, autonomous machinery, automatic guidance, variable rate applications, swarm robotics and drones, the Internet of Animals, very interesting tracking enabled by livestock wearables, organic farming, Earth observation and GNSS solutions for effective organic parcel control, Internet of Things, weather sensors, machinery sensors, Earth observation solutions in support of carbon farming, for example, in soil, high performance computing for fusion and analysis of EO data time series, together with climate forecast, video streams, sensor information, plant genomics, and other different data source, vertical farming, integrated farm management systems, blockchain, Earth observation, and GNSS support sustainable supply chain management. Next area I'm going to show you is the area number 7, is related to preserving and restoring ecosystems and biodiversity. In this area, we are looking for solutions with GNSS and/or Copernicus to enhance biodiversity monitoring, to enable data-driven precision tools for policymakers to stop biodiversity loss and support the EU Nature Restoration Plan. For example, we are looking for human pressure on biodiversity hotspots. Is really related to the different ecosystems, this area, and is mainly focused on Earth observation, as you can see. For example, water ecosystems monitoring, terrestrial ecosystems monitoring, snow and ice ecosystems monitoring, coastal ecosystems monitoring, in the field of Earth observation, and animal tracking for biodiversity purposes, for GNSS application. Obviously, those are examples, is not limited to this, the area. Let's zoom a bit on key trends. Policy commitments drive ecosystem monitoring developments on the global stage. In Europe, these are spearheaded by the new biodiversity strategy that has been published. Natural capital and ecosystem accounting efforts benefit from Earth observation services, including those offered by Copernicus, so ecosystems monitoring. The intensification of efforts to understand and protect soil health and ocean health is paramount for food security and carbon sequestration. GNSS technologies are increasingly used for wildlife tracking. So I don't know if I have still time and I can keep going, showing you some important applications in other areas, Stanislav.
I think that we can have 5 more minutes.
Okay, cool. Good. Okay, so I'm going to show you then another area related to supplying clean, affordable, and secure energy. In this case, we are looking for applications based on EGNSS and Copernicus for supply of clean, affordable, and secure renewable energy. Some example: renewable energy, energy network fidelity, environmental impact monitoring. As you can see also here is a bit uh, broad market, that broad area where you can see Earth observation, a standalone technology, or synergistic approach. For example, sorry, I cannot. Okay, for the site selection, planning, and monitoring. Then there are more EGNSS related applications such as construction, maintenance, and inspections, and so on. What I've seen regarding key trend. Okay, there are some key trends on the usage of Copernicus services. For example, uncover and relief for wind power, snow maps for hydropower or biomass mapping for bioenergy. This is leveraging the land monitoring service from Copernicus. Then solar irradiance for solar power, wind speed for wind power, offshore wind power generation, leveraging the atmosphere monitoring service of Copernicus. Then climate change information for all types of renewable energy provided by Copernicus Climate Change Service. Then we have seen a global sea forecast for tidal and wave energy, sea surface salinity and temperature information for salinity gradient power. This is, let's say, based on Copernicus Marine Services. So, regarding the trends, we have seen cutting-edge technologies combined with the EU space data and services support renewable energy and its distribution. Earth observation unfolds the potential of offshore renewable energy. Earth observation and 3D geospatial data open new horizons for solar cadastry. The proliferation of wind farms energy relies on accurate insights from you. For example, for site selection and all these kind of activities. GNSS-based timing and synchronization, we have seen those technology at the core of energy distribution systems and smart grids. I can go for the last area because I think we don't have much time, but I will share the whole presentation encompassing all the different 7 areas. Okay, the third area, area number 3 is mitigating natural hazards. Also here we are looking for EGNSS and/or Copernicus-based solution to limit the damage from fires, floods, or other natural hazards and extreme events. Example of applications: preparedness, early warning, post-event analysis, monitoring, and rapid mapping. This area is very interesting because leverage very much on the synergistic approach. As you can see, mostly of the application are in gray, so it's very interesting area in this sense. Zooming on key trends, Earth observation and GNSS are increasingly combined to provide the full picture needed for context-aware natural disaster response, boost of UAVs for search and rescue and rapid mapping, use of 3D data to support better disaster risk reduction, uptake of INSAR services across countries and regions. Okay. Should I stop, Stanislav?
Yes, I'm afraid we have to hand over in a minute to Taras. But thank you very much for your presentation, Kara. It was truly great to see what incentives the agency has for the industry in this domain where GNSS and Earth observation overlap. Earth observation in general and Copernicus program in specific. And now I will hand over to Taras, who will, I hope, give you an idea what can be done, and on this basis you will be able to come up with your ideas, with your applications, and in the future apply for a call at Horizon Europe, possibly for one of the calls that Kara has described. Taras, please, floor is yours.
Thank you very much, Stanislav. Thank you, Chiara, for the previous session. So I will start sharing my screen right now. So you should be able to see it in a second. And well, this is a beautiful island of Hawaii. And well, in a second, I'm gonna start my slides. Well, welcome everybody to this webinar, and hello to everyone from Netherlands, where I'm based today. I'm CEO and CTO of the Dutch startup called Opt/Net, or simply OptNet. Before we dive into the topic of the new services becoming possible thanks to well, Horizon projects, but also thanks to the new technology enablers such as datacubes and AI, I would like to ask you a few questions, which you might answer in the chat or just answer to yourself rhetorically, because it would help me to illustrate how urgent the need for this innovation is in our society. So first of all, how many of you have PhD in geosciences? Probably some of you attending this call, or advanced degrees, right? But how many of you also have PhDs or advanced degrees in data scientists as well? And how many of you have advanced scientific degrees in AI as well? Well, now if you answered yes to all of the above questions and also have 5 to 10 years of practical software development experience, well, raise your hands and let me know, because we will hire you right away. We hire superhumans when we see them. But anyone still? No, but well, this is why we have submitted our idea to Horizon. At that time, it was Horizon 2020 submission, which allowed us to implement this project. You know, jokes aside, but scarcity of multidisciplinary expert knowledge prevents rapid progress and inhibits our abilities to create new services for society, industry in general, and particularly in the field of Earth observations and in adjacent industries. This is why Centurion project, it's a Horizon 2020 project, which was proposed by our consortium, as was recently funded by a European Commission. So it's possible to win Horizon projects. We are a good proof of that, because we have 2 currently ongoing Horizon projects. And it is a very important funding vehicle for the innovation in Europe. The Centurion project is a research project, research and innovation project. It was 100% funded. Total budget is more than 4 million euro. And it consists of more than 10 partners. So the main goals of the project was to make analysis of large Copernicus data volumes easy. The second goal was to make access and work with the platform easy for everyday scientists and developers. And the third goal was to open new market venues, again, easy, in the process of lowering the barriers to entry and reduce the effort required from the market players to enter these markets. And the project really this Centurion project will demonstrate these ambitious goals in a set of specially chosen use cases. So the project is going to take 3 years. Now we just started it. It's in the 3rd month and the 1st quarter. And during these 3 years, 10 European partners will work as a consortium under the technical management of my company and under the administrative coordination by Inlecom Group from Belgium. So in order to create and deliver these demonstration use cases, the consortium gathered the multidisciplinary team of experts in the fields of geospatial sciences and big data, AI, ICT platforms delivery, cloud service providers. CloudFerro, by the way, is among them. So that's why we were invited to present this project here. And also, we add the public communication specialists to help us with dissemination of the project to the broad groups of people, because it's mainly about you that this project is about. and to help you develop new ideas and new concepts quickly and deploy them to the market and uptake it. But most importantly, we have also involved several thematic users who are interested in the development of the specified solutions in the targeted areas, who have the practical interest in using the developed use cases in operational phase after the research phase of the project is complete. These are WSL from Switzerland, who is interested in the forestry case, and JKI, Julius Kühn Institute, who is also acting as the agricultural policy arm for German government, who are interested in the agriculture use case. In addition, the consortium is guided by space industry leaders such as KSAT and Airbus Defence and Space, to ensure that the project remains on track on its scope and the course. They are represented as executive board of the project. So the project will consist of 3 technology groups, which we also call the technological enablers. The first one is the datacubes, but we know that datacubes are a series of Earth observation data, and we are used to work today with simple data cubes, which typically represents time series from a single instrument. The new innovation of our project is about construction and generation on demand of multidimensional, we call them data hypercubes, which extend the concept of analysis-ready data along further dimensions, which are particularly useful for analysis of long time series from different heterogeneous sensors derived from diverse remote sensing platforms, observing physically different properties ranging from backscattering of electromagnetic waves in optical, radio, X-ray, and even maybe muon spectra in the future when such data becomes available through the Copernicus constellation. AI Knowledge Pack is another technology enabler, and this technology enabler was pioneered by our company several years ago. Also represent complex nonlinear programming structures, which could be coupled with non-deterministic approach to data analysis, consisting of refined data search, processing methods, combining different settings, parameterization, metadata, AI models, supervised, unsupervised, and many other properties. And this all is combined in one compact structure, which could be rapidly replicated, portable, and could be used to build upon, especially in the open use cases, which we will make available in the scope of the project. And finally, the last innovation, we call it AI cubes. So this is where it's a pinnacle of our project, and these AI cubes will create a new data paradigm, which will help us to scale the processing capability to new heights by making the work of analysts and scientists even more efficient. AI cubes will be programmatically accessible in addition to the human natural language commands issued in written or spoken English initially. So in the future, it could be also translated into other human languages such as Italian, French, German. So here's the architecture of the solution, and I would like to draw your attention that we are building the architecture on 3 proven platforms, which have been developed with consultancy and with assistance of ESA, European Union, and other public and private funding. So these consist of 3 technologies: Optos AI, Tsar AI, who are winners of Copernicus Masters competitions in the past, and Razdaman database engine, which is also a Copernicus Masters winner. So we are building on top of Copernicus Masters champions, and the architecture here depicts how data from various sources will be accessed, transformed in the Centurion platform with these different components. The key points to take away from this complex architecture that the solution will be using existing modules from these technologies, which are already TRL 7 to TRL 8, and will use the processing and storage in the industry-leading datacube database, which will be enhanced further in the scope of the project requirements. One important point is the federated access to the existing data assets, which becomes possible. For example, if you need data set covering United States area, or the data sets covering territories in Taiwan, we could tap into the supercomputing data centers, which are part of Earth Federation server, so that we reduce the needs for duplication of the data, especially when it goes to the analysis-ready data, which should not be mixed with the raw satellite data, which is typically available in the diocese today. The analysis-ready data are the pre-processed data, which is immediately ready for consumption by your AI methods, for example. You don't need to process them, calibrate them, or to rectify, georeference, remove clouds. So all this data is ready to be analyzed. And what's more important is that mix and match AI cubes will enable rapid and easy reuse of standard and novel data processing methods developed either in the scope of Centurion project in these 5 use cases that I will describe to you, and potentially creating a new market for analytical knowledge, which we currently refer to as AI knowledge packs, or it could be also adopted under the even better name, which are the AI cubes, which everybody loves so far. The platforms will be also accessible with standard APIs by the machine clients, like your programs, your other platforms, as well as with natural spoken and written human language. It will also support easy visualizations for human users. So as I promised, I will tell you a little bit more in the remaining time about the use cases, 5 use cases, which will be demonstrated in the scope of Centurion project. We will start with the first use case, which will result in the generation of analysis-ready data. In particular, Earth observation data homogenization at the data cube preparation time versus ad hoc homogenization at the request time. So these both methods would be possible. Furthermore, other various use cases, including human versus machine clients, simple versus complex analysis, etc., will be explored in this use case. So this is a technology demonstration use case which will showcase the capabilities of the platform. And then the data produced in the use case 1 could be utilized in the ongoing use cases. So the first use case, which is the second naturally in the row, and this is about agricultural indexes. So climate change has been recognized as the main driver for the increasing occurrence of extreme weather. And agricultural weather indexes, sometimes refers to AWIs, are used to assess extreme weather conditions like drought or soil erosion regarding to its impact on the crop yields. AWIs may be based on a single variable or a combination of different variables. So designing these AWIs is typically challenging, and since it's the client to crop relations are very complex, these AWIs could be considered as a good measure, and a measure which reflects temporal and spatial behavior of the studied subjects and local conditions. So we will demonstrate how Centurion service platform can be used for creation of dynamic webs, this web-enabled AWIs, which would be presented to the Julius Kühn Institute for the further study, as well as assist them in generation of new crop-specific policies, and also studying various crop-specific vegetation cycles in the Germany, covering entire surface of the Germany. Next use case number 3, is dedicated to the maritime area, and it will be about North Sea shipping dynamics, with specific focus on our ability to detect unreported and unregulated phishing, and as well as looking for security aspects. So we are planning to monitor the entire surface of the North Sea, and the platform should be able to detect the maritime vessels with the defined area when within time period specified, and compare these detections with the available data from AS feeds. So in order to track the discrepancies. In particular, we will be looking at the area near the ports of Groningen and Bremen, which is on the border between the Netherlands and Germany. Next use case, this use case is specifically in the area of interest of WSL from Switzerland, where we plan to develop and apply method for near real-time monitoring of the forest dynamics. So forestry is another contributor to the climate change, and over the coming decades, climate change largely driven by changes in the forest cover. So the platform, Centurion platform, in the scope of this use case, should be able to produce probability maps and delineation for post-storm and post-fire damages, as well as to detect the illegal deforestations, initially in the scope of Switzerland, but also potentially move to the larger scope in the territory of Europe. And last but not least use case, this one we are planning to pick up on the fly based on the real weather conditions in Europe. And it would be near real-time near real-time mapping of the flood zones and attribution of the damages. So in this case, we will pick up the most urgent event, and we will map it based on the use of SAR data. Why SAR data is because when it rains a lot, it usually blows a lot of wind, and there's a lot of clouds and a lot of water in atmospheric column, which makes all traditional observational methods useless. So you cannot use optical or multispectral satellite imagery because they cannot see through the clouds. And you cannot use or fly drones or UAVs because it blows them away and the rain is preventing any flights until the disaster is over. Which also illustrates that typically the warnings for and evacuation orders are issued by the governments too late, sometimes 2 to 3 days after the peak of the flooding events. So because they have to wait for the assessment of the damages and the situation, which only is possible when the clouds clear up and the drones could be flown. So our methodology has been already proven in the scope of previous mapping attempts, and we are planning to demonstrate these capabilities as a dedicated use case in the Centurion platform, mainly focusing on the timeliness and on the accuracy of the attributions made by the platform. Well, on this, it brings us to some of the conclusion slides. So if you would like to follow the project, please look us at the website, look us on LinkedIn, and you can also contact me and our company for more information. And if you have something to share with us or to add, please scan the QR code. It will take you directly to the survey that we are conducting right now among the potential stakeholders and users of the platform. So let us your opinions heard. Well, thank you very much on this, and look forward to answer your questions.
Thank you very much, Taras, for this inspiring presentation of yours. Now, I'd like to talk very, very briefly how you can leverage cooperation with CloudFerro and leverage our platforms, the CREADIAS platform, in the scope of Horizon Europe calls, because we know what the incentive is, we have the inspiration, and now let's talk how it can be done, how it can be scaled up, and what profits come from using cloud platforms in general, and in a minute, and CREADIAS in specific. So as you probably all know, creating value chains based on Earth observation data requires at least dozens of gigabytes, and that's not something that you want to do locally. So that's where you need cloud platforms to either lower the cost or speed up the process. And here we come with the Creo DIAS, with one of the 4 commercial DIASes, which exactly responds to that specific EO-based application requirements for Earth observation data access, mainly Copernicus data access, but not only, with capacity to access that information rapidly, almost immediately. The information is published on the platform in near real time, especially when we're talking about coverage of Europe. It comes with cloud resources for computing, cloud resources that allow for very easy and smooth transition from small scale operations to large scale ones. To make it even more convenient, we've developed and now operate and constantly upgrade a number of tools around the Creo DIAS and around our other platforms as well. Those are tools for both cloud management and cloud services management, and for data interaction, such as the EO Browser or EO Finder. Those are two tools for data discovery, interaction, download, and selection. And we have the portal with all the knowledge required. We have a number of other applications for prototyping, for management, and so on. So, so in a nutshell, because as I said previously, we own the technology stack. We know what we do. We are able to modify basically any part of our clouds. We are willing, and we have participated in many Horizon and other R&D calls, with not only as a provider, but also as a source of expertise in this very specific domain, cross-cutting domain of the cloud and space. There will be a Q&A session responding to question in the chat. There will be a Q&A session after the presentation when I will answer this point as well, if you don't mind me. So, as I said, we are developing our own technology. We build the clouds, we operate the clouds. Those are public, private, and yes, when we participate in Horizon 2020 programs, we will surely participate in Horizon Europe calls, projects funded from Horizon Europe calls. And we like to divide that interest into two domains. The first one is more focused on cloud technology R&D. So, but it's not completely separate from Earth observation, because the specific requirement of the European space sector and stakeholders involved in leveraging Earth observation data drive us to, for example, work on data access federation and metadata federation, catalog federation, and user federation. That's something that we do. And additionally, we are looking at further enhancing our capabilities in joining scientific networks, open clouds such as the European Open Science Clouds, joining our existing different platforms such as the Creo DIAS and CODE from Germany that we've built. And in the future, we have already submitted for some the Horizon Europe calls, ideas for even further federation of European cloud resources. Those are a couple examples of R&D projects focused both on the cloud capabilities and cloud R&D, and a bit on the let's say data science R&D. This is the division that we have made. EOSC Hub, so European Open Science Cloud Hub, and the C-Skill should be of special interest here, because those are the projects that we participated, because the hub has been finished and C-Skill is running. Those are the projects aimed at Federation of European Earth observation related data and cloud resources. And on the other hand, we obviously want to enhance and participate and drive forward the efforts towards leveraging that Earth observation data. And as Chiara today said, Horizon Europe a great opportunity to create more value chains, to harvest more information from Earth observation data, and that's where we would like to help you with our experience, with what we have done. And with our resources, because we currently operate, I think, over 25 petabytes of Earth observation data, with really big pool of cloud computing resources. We have more than 90 petabytes of online storage ready to be used in case there is a great application that requires storing and disseminating information. We have tested our abilities to disseminate over 2 petabytes of data daily, and all that we want to be used for Earth observation related applications that leverage Copernicus data, that combine Copernicus data with other data sources. All those things that Horizon Europe calls are calling for, however repetitive that may sound. And this we want to push towards this, one of the ultimate goals of the European Union now, led by the European Green Deal. We want to enhance European industries and societies' sustainability, lower its carbon footprint. Just take this small, have our small part in the joint European efforts, and this can be done with us, and so we invite you very, very much to approach us. We can both work with you on developing cloud capabilities in Europe, and we can work with you on supporting your ideas for Earth observation-based applications. We can help you. We can provide you with an expertise, and that's cloud space domain that we have built over the last over 7 years working for European Space Agency, EUMETSAT, ECMWF, German Space Agency, and it's all we want to use. It's all we want to leverage, so that we can achieve those very ambitious goals set in front of our eyes by the Horizon Europe program. So thank you very much. I would like to point your attention now to a bit lighter topic. We have concluded a contest for most stunning, most capturing and captivating satellite images, caught or stored in our repository. And so just take a look at the winning submissions freewheeling submissions from our users. This is less technical, but the more stunning, even more stunning side of Earth observation data. I would like to thank a lot our guest speakers. Once again, Chiara, Taras, thank you very much. It was very interesting and very insightful, and I hope that we have managed altogether to provide some inspiration to others, and that I hope that this presentation also not solely will be a basis for great projects funded from the Horizon Europe calls. And I would like to thank also all of you for joining us, for dedicating your time to our webinar. And I would like to invite you to further webinars that we will be hosting regarding different topics. Thank you so
very much. Thank you, Stanislav.
Thank you very much to CloudFerro and to the audience for your attention, and to my co-speaker, Chiara, for doing this presentation, and to Stanislav. Thank you very much.
Thank you, and looking forward to receive your innovative ideas.
Indeed, good luck with your applications. It can be done.
Bye-bye. Have a nice evening. Thank you.
Bye-bye.